Hello, everyone. Welcome to September 17th physics video. Uh, all right. Today we actually started taking some notes on Chapter 2, Kinematics. Hopefully you guys can pick up your books today. The pickup is 3 to 5:30. Yeah. But today we're going to take some notes, and I will assign some homework. The homework, I am not collecting it till Tuesday. I will go over the answers, and then we will have a quiz on Wednesday. Okay. So we're going to get started. If you need to pause the video at any point throughout the video, go ahead, pause it so that you can catch up on notes, and we will move on. Okay. So first and foremost, what I like to do is I like to create a video that has different little characters. So we're going to talk about the adventures of Jim and Cindy. Okay, so here we go. All right, two different definitions. The first one is one dimension. All right, one dimension is a straight line that's going in a direction. All right, so it can go left, right, up, down, east, west, north, etc. Where kinematics is the study of motion using words, numbers, graphs, and equations. All right, that's what our focus for this first two chapters are going to be. All right, like I said, you can pause the video whenever you need to. Okay. Now we're going to be talking about scalars and vectors. Now, a scalar, it's just the magnitude. It's just a numerical value. Okay. Whereas a vector is a numerical value with a direction. So for example, I am heading 5 meters south. That has my magnitude and it has a direction. So that's my vector. Okay. Next, I want you guys to try some of these examples out. Okay. Please pause the video now. All right. Now, hopefully you got these done. 5 meters, that is just a magnitude. All right. So that is a scalar. If you have 30 meters per second east, all right, east is big, so that makes it a vector. Okay. 20 degrees Celsius, another scalar. 400 calories, scalar. And, oh, this is my tricky one. Negative 10 centimeters. If there's a negative, that negative represents a direction, all right? It means left, west, south, down. Down is another example, okay? That one's a little tricky. So that one's actually a vector because it has a direction. Okay. Distance versus displacement. Let's see. Let's make that right there. Hopefully you can see it. Distance, a scalar quantity that refers to how much ground is covered. All right. So it's just the total distance. It's just a number. Where displacement is a vector. Okay. A vector quantity that refers to how far your ending point is from your starting point. Okay. Okay. Like I said, you can pause it whenever you need to. Now, I do have a video. It's of a ball rolling back and forth. It doesn't show. Okay, so I'm just going to skip that. Now I have some example problems, okay? And what I'm going to try to do, as I mentioned, we're going to talk about the adventures of Cindy and Jim, and a third character called Harry. Okay, did I skip one? There we go. Sorry. Oh, don't look at those answers. Okay. Jim travels 60 meters east to go to Cindy's house. So right now, Jim is way over here. He travels 60 meters to go see Cindy. Cindy is not home, so he decides to go 40 meters west to Harry's house to hang out with Harry, because Harry's so cool, you know. Everybody wants to be with Harry. What was the total distance? All right, so the total distance, I would add up my two values. So total A is 100 meters. Okay. Since it's just a distance, all I got to do is 100 meters. What is his displacement? Well, if I traveled 60 meters that way, 40 meters that way, your displacement is 20 meters east, okay? Or right, or if you just left a positive 20 means east as well, okay? All right, Cindy notices Jim coming to her house and then Cindy noticed Jim coming and she decided to run 150 meters to the east. All right, so Cindy went 150 meters that way. She's like, I'm booking it. All right. Afterward, she's like, all right, I want to go hang out with Harry too. So Cindy goes to Harry's house, which is 40 meters west. Oh, so she decides to go all the way back to Harry's house. Okay. What was her total distance? Okay. If you need to pause it, pause it. Okay. But her total distance, well, 150 this way, 150 back, and then 40 meant 40 to Harry. So if you add up 150, 150, and 40, the total distance should be 340 meters. 340 meters. Okay. And what is her displacement? Well, her displacement is only 40 meters west. Or if you put negative 40, that would be correct as negative 40 meters. That would be correct as well. Okay. Now, big problem here. All right. Pause the video, try it out. So ask, what is Jim's displacement? Okay, so first he traveled to the grocery store, went to see the penguin, all right, went over to Cindy's house, and now he's at the grocery store. Okay, what was his total displacement? Well, that would be 200 meters, okay, because that is the distance from his house to the grocery store. What is X? Okay, so what is X? Hopefully you saw that from Cindy's house to the bird was 125 meters. Well, from the bird to the store was 50 meters. So if you took the difference, your answer is 75 meters. Okay. What was the total distance? Well, Jim traveled 200 to the grocery store. He traveled 50 to the bird. Traveled 125 to Cindy's house. Then he traveled 75 back to the grocery store. So that's 250. So if you add it up, it should be 450 meters. Oh, that's a terrible circle, sorry. 450 meters. And then last but not least, how far does Cindy live from Jim? So what is our distance here to here? Well, if I know Jim's house to the grocery is 200 meters, and I know X is 75, if I subtract those two, we're left with 125 meters. Okay. So home is always where your displacement is, okay? It's home base. That's where you're starting, and that's where you're going to find out your displacement is 0, okay? Last slide. It's a conceptual problem, okay? So can you drive your car in such a way that distance it covers is greater than the displacement, B, equal to the displacement, or C, less than the magnitude of its displacement? All right, so if you need to try to answer in this, pause the video. Okay, so can I drive a car in such a way that the distance is greater than displacement? Yes. All right, if I drive in a curve or a circle, My distance is very large, however, my displacement is very short. So A is yes. B, can I drive that in a way that my distance is equal to my displacement? Yes. The answer is if you go in a straight line. Straight line. And then C, the answer is no. There's no way to have the distance less than the displacement. Okay. Okay. I hopefully that helped out. I tried doing a recording of my Google Meet with my live Google Meet, but that didn't work, so I had to go to Plan B. But if you guys have any questions, shoot me an email. I am assigning the homework. You can find that under the classwork tab. Once you do, like I said, I am not collecting that till Tuesday. All right, collecting that on Tuesday. Anyway, hope you guys have a great day. We will see you later.